Definite integral 6, Riemann sum to integral. Express the limit of the sum as a definite integral of the form 0 to 1 f of x dx and 0 to pi over 2 f of x dx. Limit n goes to infinity, summation I goes from 1 to n, sine of pi over 2 times I minus 1 over n times 1 over n. Recall the left endpoint Riemann sum formula. Limit n goes to infinity, I goes from 1 to n, f of xi minus 1 delta x, that's equal to the definite integral a to b f of x dx. With regular partitions, delta x is equal to b minus a over n. We let xi minus 1 be equal to I minus 1 over n. I goes from 1 to all the way to n. So plugging I equals 1 here, we get x0 is equal to 0. Plugging I equals 2, we get x1 is equal to 1 over n. x2 is equal to 2 over n. xi minus 1 is equal to I minus 1 over n. And xn is equal to xn minus 1 is equal to n minus 1 over n. So we know that a is 0. To find b, take the limit as n goes to infinity, n minus 1 over n. This is clearly 1. So that's b. So now we have a is 0, b is 1, and xi minus 1 is equal to I minus 1 over n. The function is f of xi minus 1 is sine pi over 2 times xi minus 1. And that means f of x is sine of pi over 2x. And delta x is b minus a over n. And that is 1 minus 0 over n. So we have been able to transform the Riemann sum, limit n goes to infinity, I goes from 1 to n, sine pi over 2, I minus 1 over n times 1 over n, into a definite integral of the form 0 to 1 sine of pi x over 2 dx. Now the second part of the question is to rewrite this Riemann sum to transform it into a form like this, 0 to pi over 2 f of x dx. So we're going to let xi minus 1 be equal to all of this, pi over 2 times I minus 1 over n, as I ranges from 1 to all the way to n. So plugging I equals 1 into here, we get x0 is equal to 0. Plugging I equals 2, we get x1 is equal to pi over 2n. Plug in x equals 3, we get x2 is going to be equal to pi over n. xi minus 1 is going to be pi over 2 times I minus 1 over n, and xn is going to be, xn minus 1 is going to be pi over 2 times n minus 1 over n. So clearly a is 0, and b is going to be equal to pi over 2. How do we know that? Well, we can take the limit as n goes to infinity of xn minus 1, that's pi over 2 times n minus 1 over n. And if you divide by the highest power, divide by n, you can clearly see that this limit will approach pi over 2. And that's b. Okay, so a is 0, b is pi over 2, and f of xi minus 1 is going to be sine of xi minus 1. That means that f of x is sine x. Now we have delta x is equal to b minus a over n, which is pi over 2 minus 0 over n. That's pi over 2n. But we don't have this showing up in the Riemann sum, so we have to do some algebraic manipulations. So what we have is limit n goes to infinity, summation I goes from 1 to n, sine of pi over 2 times I minus 1 over n times pi over 2 over n. This is the delta x that we have developed here, but now we have to compensate by multiplying by 1 over pi over 2 so we don't change the original question. Now what I'm going to do is factor out this 1 over pi over 2 and put it in front of a summation. It passes right through the summation, so I'm going to get 2 over pi summation 2 over pi limit n goes to infinity, summation I goes from 1 to n, sine of pi over 2 times I minus 1 over n times pi over 2n. This is equal to 2 over pi integral from 0 to pi over 2 sine x dx. Notice that we've done this in two different ways. We've expressed the Riemann sum in terms of from 0 to 1 f of x dx, and that's this one here. And also we've expressed the same Riemann sum in terms of 0 to pi over 2 f of x dx. So we had to do some algebra, and we also had to choose our x slightly differently. And there it is. And this is the transformed definite integral. All right. Thank you.